Okay, we're going to start with 11.6, the first part, which deals with counting principles. The reason that we do this is we have a lot of different situations that we need to be able to count the number of total outcomes because this leads right into probability. If you want to find the probability of something happening, you need to know how many total ways it can happen first and then find the probability of the one that you're looking for. So this comes up a ton in the real world, lottery, games. It comes up in insurance, if you're a insurance adjuster, you want to know what's the probability that certain events would happen. So counting principles are really fundamental, and that's really how they came about historically, was from things like insurance and investments and games and of course gambling too. So we are going to look at a couple of these things. So we are placing 8 pieces of paper. They're numbered 1 to 8 in a box. We draw out one piece of paper at random, write down the number, and then put the paper back, and then you're going to draw a second piece of paper. And then record its number, and then you're going to add the two numbers together. So how many different ways can you obtain a sum of 12? Well, the first thing is if you draw a 1, 2, or 3 on the first pick, so if you draw the number 1 out of the box, or 2 or 3, there's no way that you can get a sum of 12 because the numbers only go up to 8. So in order to even have a chance at getting a sum of 12, on your first draw, you would need to pull out either a 4, 5, 6, 7, or 8. Okay? Now, on your second draw, if you had a 4 on the first one, now you need an 8 in order for them to sum to 12. If you'd drawn a 5 first, now you need a 7. If you drew a 6 first, now you need a 6. If you drew a 7 first, now you need a 5. If you drew an 8 first, now you need a 4. Okay? And all of these are different ways that you could draw two numbers that add up to 12. And so our answer is there are 5 ways. Now, going to our next problem, we're going to repeat this process, but this time we do not replace the papers in the box. So how many ways can we obtain a sum of 12? Now, the same thing, if you draw a 1, 2, or 3, there's no way you can get a sum of 12, so we can kind of ignore those. Since we're not replacing, that means we have to throw out this one, because if I draw a 6 the first time, there's no way that I can draw a 6 on my second draw. So now my only possibilities are the 4, 5, 7, and 8, and then of course on my second draw, 8, 7, 5, and 4. Okay, so now there are only 4 ways because, like I said, we're not replacing those, so we can't draw a 6 and a 6. This leads us into something we call the fundamental counting principle. You are very familiar with this. If you have 2 different events, if the first event can occur in M1 different ways, and then after that the second event can occur in M2 different ways, then the number of ways that the 2 events can both occur is you just multiply those. So for example, a combination lock will open when you select the right choice of 3 numbers. Okay, you have to have the right numbers, you have to have them in the right order. How many different lock combinations are possible? So I'm going to draw blanks. Here's the first number, here's the second number, and the third number. I'm going to write down all the different possibilities and then just multiply them together. So for my first number, I have 30 different choices. 1 to 30. For my second number, I also have 30 different choices because I'm allowed to repeat numbers. And for my third number, I have, again, 30 different choices. Okay, because my combination lock could be 1, 1, 1. It's not a very good lock, but whatever. So we multiply those together and we have 27,000 possible combination locks. Likewise, telephone numbers have 10 digits. The first 3 are the area code. So how many different telephone numbers are possible within each area code? Okay, so notice, we're not talking about all 10 numbers. We're saying, in the area code, let's say 419, and then there's 7 more numbers. Okay, so in this area code, how many things can we have? Now, with a local telephone number, you cannot begin with a 0 or 1. Okay, so this one cannot be a 0 or 1, which means that it can be 2, 3, 4, 5, 6, 7, 8, or 9. So we have 8 choices here. Remember, this 419 is not part of our problem. Okay. Now for our second number, it can be anything. It can be 1, 2, 3, 4, 5, 6, 7, 8, 9, or it could be 0. So we have 10 choices here. We have 10 choices here, and on down. And only restrictions we put on this was the first digit could not be 0 or 1. So we multiply these all together, and we end up with 8 million different phone numbers that are possible in a given area code.